just a basic tutorial on how to not only determine the line of reflection, well, actually not even determine the line of reflection, but do, in my opinion, the much harder feat of actually reflecting the shapes. Okay, so before we start, I want to talk about, so when you're reflecting, what you want to do is count the number of squares it takes to get to the line, and by the line, I mean the line of reflection, and then travel that distance after you reach the line of reflection. So say line O is the line of reflection here, and your shape, or I'm not even going to do a shape, I'm just going to do point X. So say it takes, say, about half a square to reach the line of reflection. So you want to travel half a square onwards in the same, and make sure it's in the same direction as you're going. And then you'll have a reflected version of X across line O. Alright, so let's get into some example problems. So I'm just going to move this out of the way for now. So to get A, it takes 2 squares to get to this line. So you count another 1, 2 squares after it, and that's where it'll go. So A's here. So now B, it takes 1, 2, 3, 4, 5, 6 squares to reach the line. So we'll go 1, 2, 3, 4, 5, 6. So right about there. Now for C, it takes 1, 2, 3, 4, 5. And by the way, 1, 2, 3, 4, 5. So yeah, and you can tell this is the right answer because they both have a right angle and the triangles look incredibly similar. And also, if you get this on a coordinate plane, what you can do is, and this works better if you have larger numbers, rather than just counting all of it, you can just take the number and then subtract the amount it would take to get to 0, or on your x or y coordinate, and then and then take that number. So say it was -7, and then and you were doing it to the x coordinate, or actually no, you're doing it to the y coordinate. So you had, your number was 0, -7, or +7 originally, and then it took you 7 to get to the origin, which is 0, 0. So then your new point would be 0, -7. So essentially it's 1 point, and then the other point is just how many squares it took you to get to the line of reflection. Alright, I'm going to get back into the examples here. Okay, so plot the image of ABCD under reflection across line Y. So C is actually going to be in the same spot, because if any point is on the line, it just stays there because it's 0 points from the line. Let's see, I'm just gonna rotate this a little to make it easier. Okay, and B is 1, 2, 3 units from the line. 1, 2, 3. And actually, weirdly enough, the rest of the triangle got in place because, as you can see, D is 1, and then 1, and A is 1, 2, and then 1, 2. Oops. So that kind of worked out perfectly. I wasn't intending that, but alright. So I only had to do 2 points. Bonus. Alright, 2 more. Okay, so A is on the line, so we'll just put it there. And also make sure you're paying attention as to if it's the x or the y-axis, because even though it in this case it was the x, because it seems like it would be the x, but they could also rotate it across the y, and if you don't look at that, you don't know. Alright, so now, okay, so C is 1, 2, 3, 4, and 1, 2, 3, 4. So right there. And B is 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. And as you can see, these shapes are pretty similar. And yeah, make sure, like, whenever you're doing this is another tip, make sure, like, the shapes look pretty similar. Like, they should look like the same general shape, it's just in a different place. And they'll stay congruent, because this is a type of rigid transformation, which means it might move its location, but it doesn't change its size. Plot the image of quadrilateral ABCD under a reflection across the y-axis. Okay, so it's going to go across there. Alright. So, B is 1, 2, 3, and 1, 2, 3. C is 1, 2, 3, 4, 5, and 1, 2, 3, 4, and 5. Alright, now A is just 1, 2, and 1, 2, so that was already in place. Which actually happens a decent amount, weirdly enough. 1, 2, 3, 4, and 1, 2, 3, 4. Alright, so as you can see, this is a pretty similar copy, and it also has the same right angle. So yeah, so that's what I'm gonna put. So yeah, everyone, thank you for watching. I hope this video helped you, and yeah, good luck on your homework. Bye.